Hi everyone, this is Pavitra working as an assistant professor in STEAM Muthukumaran Institute of Technology. Today we are going to see lecture on signal processing BM3401. These are the core objectives of the signal processing subject: to understand about the continuous and discrete time signals and systems, to also know about the LTI systems, to know about the FIR filter and IAR filters, and also about the FFT of the signal. These are the course outcomes of the signal processing subject, and these are the 5 units in the signal processing subject. Today we are going to see about Unit 1, Fundamentals of Signals and System. Fundamentals of Signals and System. Already in previous videos we have seen about what is signal and what is system, what are the types of signals we have, and what are the characteristics that signal will have, and what are the operations will perform on the signals. Everything we have seen in the previous video. So now we come to the end of the unit. We are going to know about the sampling and the quantization of the signal. Sampling is a process of converting continuous time signal into the discrete time signal at samples at discrete time intervals. This process is called sampling. Sampling analog signals makes them discrete in time but still continuous value. Sampling done by it should satisfy the Nyquist theorem, then only sampling will be done. Sampling interval will be in the time interval between samples will be Ts. If the signal is slowly varying, then fewer samples per second will be required than if the wave is rapidly varying. So optimum sampling rate depends on the maximum frequency component present in the signal. Methods of sampling: ideal sampling and impulse at each sampling instant. This is the ideal sampling method. Signals will be sampled at each instance of time. This is discrete time signal. This is the sampling time period. And next one is natural sampling. Pulse of short width with varying amplitude with natural tops. This is the continuous time signal. This method is natural sampling method. And this is flat top sampling. Here signals will be flat topped for each time interval. So this method is flat top sampling. And these are the different kinds of sampling methods to convert the continuous time signal into the discrete time signal. Next we are going to see about the quantization of the signal. Quantization is a non-linear transformation which maps elements from a continuous into a finite set. It is also the second step required by the A to D conversion. First, signal will be sampled and discrete. Output of the sample signal will be discrete but continuous value. Then it is given to the quantizer unit. We will get the output as digital signal, discrete time, discrete value. To convert the continuous value into the discrete value, we are using quantizer here. This is the uniform quantization. Here, this is the quantization process. Here we will have input here, input in x-axis and output in the y-axis, and delta is the step size, delta equal to 2v by 2 power n, and v equal to 2 power minus n plus 1. This is the uniform quantization method. This is quantization error. See the difference between these two. We will have error like this. Error will be minus delta by 2 to delta by 2. This is the error signal. Quantization error and its classification. What is quantization error? What is quantization? Conversion of an analog sample of the information into the discrete form. That is, discrete time with continuous value converted into the discrete time discrete value. Quantization error is defined as the difference between rounding of sample values of analog signal to the nearest permissible level of the quantizer during the process of quantization. Classification of quantization process: uniform quantization, non-uniform quantization. And so this is uniform quantization method. And quantization error is the rounding of the samples to the nearest permissible level of the quantizer, that is rounding off. That rounding off is known as quantization error. So we will have quantization error like this. So we have seen about what is sampling, what condition should satisfied by the sampling of the signal, that is Nyquist theorem. We have to satisfy the Nyquist theorem, and we have seen about the different types of sampling methods, and we have seen about ideal sampling, natural sampling, and finally we have seen about the flat top sampling. And we have also seen about the quantization, what is quantization, what is uniform quantization, and what is quantization error. Everything we have seen in this video. Thank you. For more videos, please subscribe Sri Muthukumaran Institute of Technology YouTube channel. Thank you.